Alright, here we're going to be learning about inequality word problems. So we've learned how to solve any type of inequality you're going to come across. Now we're going to be given a scenario and you're going to need to translate it into an inequality and then possibly solve that inequality. So these are just some of the commonly used phrases that we have with inequalities. Each of these is matched up with their symbol. So if I say something's below 40, that means it's less than 40. This is kind of just a word bank that you can come back to if you're confused on these. I'm going to actually just go through these examples and maybe reference that chart. So we have two scenarios here that are really going to be simple inequalities. First one says you must be a minimum of 44 inches tall to ride Space Mountain at Disney World. You have to be 44 inches or taller. That's what a minimum means. You could be 45, you could be 46, but you have to be 44 or more. So to write that inequality, we would say x is greater than or equal to 44. You're at minimum 44 inches. So we're going to shade in the heights in inches of people that can ride Space Mountain. Well, 34 inches, they can't. 50 is bigger than 44, 43 is not, 19 is not, 60 and 44 both work. It says it could be equal to 44 or more than that, so 44 is a solution there. Second one says a bag can hold fewer than 20 cans before it's too heavy to carry. So it can't carry 20 cans, it's fewer than 20 cans. So x is less than 20. It's not equal to it, it's saying it's specifically fewer than 20 there. So we're going to shade in the amounts of cans that the bag can hold before it's too heavy. It can't hold 20, definitely can't hold more than 20, but it can hold any of these values that are less than 20. Otherwise it gets too heavy. Alright, so those are really just simple inequalities where you don't even have other operations in there. It's just the inequality that you have to write. Now we're going to get into two-step inequalities. So this example says you have at least $100, you have to have at least $100 in your bank account to avoid a fee. So if you go below $100, then the bank is going to charge you a fee. You have $15 in your bank account right now, and you make withdrawals of $20 per week. So I just kind of highlighted the key information here. For how many whole weeks can you withdraw money and avoid the fee? The question is always going to highlight our variable. That's going to be our variable in this case, or let's change that to W. It's asking how many whole weeks can we withdraw money. That is the thing that we don't know, so it's the unknown, it's the variable in this scenario. Which inequality represents that scenario? So we have to have at least $100, so we know whatever money we have in the account has to be bigger than 100. So I'm looking at these options. This is saying, I don't even know what this expression is showing right now. I just want to look at the inequality symbol. That's saying that amount of money, which is the money in our bank account, is less than 100. That can't be true. Same thing here. That's saying that the money we have in our account, the $315 and whatever we withdraw, is less than or equal to 100, but that can't be true. That's not what we want. We want it to be bigger than 100. So it's got to be one of these two with the inequality sign pointing towards the 100, showing that the money that we have in the account is bigger than 100. So now we're just deciding, is it a plus sign or a minus sign? So we start out with $315. That's the amount that we start with, and we're withdrawing $20 per week. So each week we're going to lose $20 from that 315. That's why it has to be subtraction. It's 315 starting out in the account, and then we're taking away $20 each week, and we want that amount to be greater than or equal to 100 so we don't get charged a fee. So letter B is saying if the answer is W is less than or equal to 10.75. So that's saying when we solve this inequality, that's what we get. How many whole weeks can we withdraw money for and avoid the fee? So the big thing in here is that we're not getting a half of a week. It's talking about the whole number of weeks. So we just want to decide, is it 9, 10, or 11? Well, it's saying W has to be less than or equal to 10.75. So 9 would work. That's less than 10.75. But it's not the first integer less than 10.75. Really, 10 is. So that second option has to be right. It's less than 10, but it's still a whole number. 11 is too much. Yeah, I mean, 10.75 does round up to 11, but we can't afford the 11th week. We would go below that $100. A couple more scenarios here with just two-step inequalities. Michael went to the carnival with $22.50. He bought snacks for $5.75, and he wanted to spend the rest of his money on ride tickets. Each ride ticket costs $1.15. What's the maximum number of ride tickets Michael can purchase? Okay, so we can't spend more than $22.50. Actually, I'm going to start with that on the right side. I'm going to say that's the amount of money that he has to start, and whatever he's going to spend, it's got to be less than or equal to that amount. The money that he spends, it can't be more than the money that he has. So now we just have to figure out how we're going to represent the money that he's spending. Well, he already bought snacks for $5.75. Plus, he's going to spend $1.15 on each ride ticket. That word each is telling us where that multiplication is happening. For each ride ticket I get, I'm going to multiply it times the cost of the ride ticket, which is $1.15. So that's going to be 1.15 times x. The number of ride tickets is our x. Again, that question really gives away what your variable is. It's asking, what don't you know yet? What is the number of ride tickets? Well, that's what you're going to solve for in this inequality. All right, we actually have to find an answer on this. So that's the inequality we're representing. And now we're going to solve this. We're going to cancel out the 5.75 on both sides and get down to 1.15 times x is less than or equal to 16.75. Then we have one last step. This is multiplication, so we're going to cancel that out with division. Divide by 1.15 on both sides. And we get that x is less than or equal to, I'm just going to round this, 14.57. But I can't buy a half a ticket. That just doesn't make any sense. I'm looking for a whole number of ride tickets. So I'm thinking about what's the biggest number that I can actually buy that's less than 14.75. That's just going to be 14. I can't buy the 15th ticket. I don't have enough money for that. Or Michael doesn't have enough money for that. On the fifth one, the Starbucks manager is ordering new aprons and needs at least 25 to have enough for all of their baristas. The aprons are sold in boxes of 4. If the store already has 3 aprons, what's the minimum number of boxes that must be purchased for everyone to have an apron? So I'm going to think about this kind of the same way I set up the other one. I need 25. So this is how many I need. And I need the left side to be bigger than that, or equal to it. It could be equal to 25. But I need at least that number. I could go 25 or higher. But this is what the store has on the left side. We're starting out with 3. Has 3 already. Plus, we're thinking about adding more boxes to this. Plus 4 aprons for each box. Starting out with 3, adding 4 for each box, and we want that to be bigger than or equal to 25. All right, now we can solve this to figure out how many boxes we actually need. So we're going to subtract 3 from both sides. Get 4x is greater than or equal to 22. And then last step, we're going to divide by that 4. And get that x is greater than or equal to 5.5. So we need at least 5.5 boxes to have enough aprons. Well, we can't buy half a box. We need to buy the 6 box so that we have enough. We're going to end up with 27 because this is boxes of 4. But we need to buy that 6 box just to make sure we have at least 25. All right, on the back, we're going to get a little bit trickier with this. Actually, here we're just going the opposite direction. We're going from the inequality to one of these scenarios. 7 and 8 are going to be a little bit tricky. Those are multi-step. So which verbal situation would be translated into the inequality below? So a catering company charges a flat rate of $28. I could keep reading, but I'm done there. I know that that's not the right answer. A flat rate, that phrase flat rate, means it's one time. But I see in my inequality, 28 is being multiplied by a number. This could be the flat rate. We could start out with 50 and then add 28 per whatever, but we can't have a flat rate of 28 if that's being multiplied by our x. And you can see the next part of that sentence, $50 per meal, that's where the multiplication's happening in that scenario, so that can't be right. Second one says a gym charges a fee of $50, so that's a good start. Just a one-time fee of $50 and $28 per month. That's exactly what that's saying. $50 to start, just one time, and then $28 for each month. If you have a maximum of $400 to spend, how many months can you join the gym for? Well, saying you have a maximum of $400 means we're going to spend less than that. This is what we spend. This is what we have. We want the amount that we spend to be less than or equal to that amount, which that looks good. I'm going to read the last scenario just to make sure, but to me, right now, that one looks good. If you need a minimum of 400 points to win a video game, actually there I'm done reading also. I could read the rest of it, but if I need a minimum of 400, that means I need more than 400 points. It's going to be something that's bigger than 400 to earn whatever that's talking about. So that one's out too. It's got to be that middle one. All right, now we get multi-step inequalities. These take a lot of thinking, okay? So we're going to try to write the inequality first and then figure out the actual answer to that question. So a parking garage charges $2.50 for the first hour, and then $3.50 for each additional hour. Dorian has $30 left in his parking pass. How many hours can he park for? So I'm going to start this the same way. I'm going to just put 30 on the right side and think about what inequality symbol I need to write here. Well, I can't spend more than that, so it's going to be less than or equal to whatever I spend has to be less than or equal to that 30. Alright, now for the amount that I spend. Well, I'm spending $2.50 for the first hour. So I'm going to start with that. $2.50 for the first hour, plus I'm going to spend $3.50 for each additional hour. Now you might be thinking, well, it's each, so it's just going to be $3.50 times x. Or let's actually call that h for hours. The problem with that is that's including all of the hours, including the first hour. But we don't want to pay again for that. This is saying that h would be all of our hours together, including that first hour, but we already paid for that. So you don't want to include that. You want to take that away from that h. So we're going to say $3.50 times h minus 1. We already paid for that first hour. So this is the total hours minus that first hour. That's what we're getting charged $3.50 for. All right, now we are going to solve this inequality by distributing. We're going to take that 3.5 and distribute into the parentheses. So we have 2.50 plus 3.50 times h minus 3.50. I multiplied the 3.5 into both terms inside the parentheses. Now I'm going to combine like terms. There's no variable on either of those two. Those are constants, so I can put those together. I'm just going to shorten this to 3.5, and that's just negative 1. I'm going to keep solving. I'm going to try to get h by itself by canceling out the minus 1, giving me 3.5h is less than or equal to 31. And then we divide by 3.5 on both sides to find out that the total number of hours has to be less than or equal to 8.857. It's got to be less than 8.857. I don't really even need the rest of that those decimals. It's got to be 8 because I can't afford the 9th hour. Once I see that that's 8 and a little bit, I'm not going to afford the 9th hour. I'm just going to afford up to 8. We're only talking about whole number of hours. How many hours? I think that's implying whole number of hours here. So we're just going to be able to afford the 8th hour. All right, last one. Virginia County Marching Band is selling candy bars for a fundraiser. Jocelyn sold some candy bars. Non sold twice as many candy bars as Jocelyn. Together, Jocelyn and Non sold no less than 45 candy bars. Right, 3 possible amounts of candy bars that Jocelyn sold. All right, so first I'm going to set up that inequality. Jocelyn and Non together. When it says that, I'm thinking J plus N sold no less than 45. So they could have sold 45, so it could be equal to 45, or it could be bigger than 45. We know they sold at least that amount. So their amounts together, those two added together, is greater than or equal to 45. Problem is, now I have 2 variables. I can't really solve an inequality like that yet, but this is giving me a hint as to how I'm going to solve that. Non sold twice as many candy bars as Jocelyn. So I'm going to think about how to represent that first. Non, his amount, would be twice as many as Jocelyn. So it would be 2 times as many as Jocelyn. I just want to think about examples in there. Let's say Jocelyn sold 5. 2 times 5. I just want to make sure that this really makes sense. Then Non would have sold 10. I want to make sure that that's really what that's saying. Non sold twice as many. Well, this is saying Non sold 10. Jocelyn sold 5. So this equation does represent that scenario. Non is 2 times whatever the value of Jocelyn. Right, now we get to the really tricky step here. So that part, I kind of think you might have understood intuitively, but then what do you do from there? Well, if we know that N and 2 times J are the same amount, we can substitute this expression. I'm going to rewrite this just so it's not so sloppy. If N equals 2J, we can take that expression, we could take 2J and put it in place of N in this inequality. So this is Jocelyn's amount plus Non's amount, which is 2J. Those are the same thing. We just said that those are equal to each other. So instead of the N there, I'm going to substitute in 2J, which is the exact same thing as N, and say that that is greater than or equal to 45. That is a really tricky step. We're substituting in an expression for something that we know it's equal to. So in place of that N, we took that 2J and put it in there, because we know that they're the same. Now we can actually solve the inequality. That would give us 3J just by combining like terms. And then we would divide by the 3 on both sides to get that J has to be greater than 15. Greater than or equal to 15. So this is asking us to write 3 possible amounts. Well, it's something that's greater than or equal to 15, 15, 16, 17, all of those work. And I just want to make sure that this actually makes sense with the question that was asked here. They're selling at least 45 candy bars together. So this is Jocelyn. I'm just going to write Non's amount above that. Non sold twice as many. So twice as many as 15 is 30. Twice as many compared to 16 is 32. Compared to 17 would be 34. So that would be Non, because he's selling twice as many. And if I think about adding these together, that would be 45. That would be 48. That would be 51. So that's exactly what I'm looking for. I'm looking for numbers that are no less than 45. So together they did sell 45 or more. All right, I know that was a lot. Hopefully it made sense. If it doesn't, go back, rewatch whatever you need to rewatch to make it make sense.